In this video, I'm going to go through a couple of the blood tests that we'll run through. So this can be a review that you can use as you're going preparing for the test. So the first one we're going to talk about here is the hematocrit. Okay, the hematocrit. The hematocrit, if you remember, by measure is the percent of red blood cells. That's the hematocrit measure. If you remember, for males, it's higher than in females because of testosterone levels. So what this is we've taken a blood sample and we've centrifuged it. So the heavier elements, the formed elements, the red blood cells, the white blood cells, and the platelets have sunk, and the plasma has stayed to the top. And the plasma, remember, is mostly water and has that yellowish look to it. So what you do is you line this up. There's a big range here because it depends how much blood you get or how filled you get this capillary tube. Okay, how far you get filled up. So if you get it filled up here, it would go in a different place than it is now. If you only got it filled up to here with blood, then it would move down. Okay, and I'll show you that in a second. This part right here, this is just what you use when you fill it with blood to keep it from flying out. When you stick it in a centrifuge, you put this little piece of clay there. So that's the clay. This is the red blood cells here, from here to here. The buffy coat, the platelets, and the white blood cells are a thin layer here, which again, you can barely see it. So you don't really worry about it for this measure. And then here's your plasma, and there's the top of the plasma. So where do you line it up? Do you line it up down here? Do you line it up over here? What you do is you line it up so that the top of the plasma is at the 100%. So if you had less, then you'd have to move it down farther. If you had more blood in it, then you'd have to move it up. Okay, so the top goes at 100%, the plasma goes at the top, and then the 0 goes where the red blood cells start. You don't want to count the little clay piece here. So this goes at 0, and this goes at 100%. Again, it may go higher, it may go lower. In some cases, you even have less blood than this, and you'd have to use a different type of chart. Okay, so then based on that, this is at 0, this is at 100. You figure out what percentage is the red blood cells, which is right here. And then what you do is you slide across here. You can go either way. You slide across here, and it is about 40%. Wait, let me check that. My eyes are bad. It's about 45%. Sorry, it's about 45%. So it hits this line right here. You come across. Notice it doesn't make any difference whether you come here. You hit that line right here. You follow that line across, and you're at about 45%. So the hematocrit would be 45%, which, if you knew if it was male, females, would be kind of higher in males, not as high in females. Okay, so that's hematocrit, the percent of red blood cells. This next one tends to confuse people. So we went over this in class, but I'll go over it again with you, or you can watch this before we even go over it in class. So if you want to determine a person's blood type, okay, so remember, you got to remember who has what antigens and what antibodies. We are concerned about the antigens that are on the red blood cells. So we're trying to determine which antigens are on a person's red blood cells, and that will determine blood type. Because remember, type A has A antigens, type B has B antigens, type AB has both A and B antigens, and type O has neither A or B antigens. Okay, has neither A or B antigens. So what you do is you take some blood, which we don't do in this class, but if you take some blood and you put 3 drops, and actually there's 2 here. You put 1 drop here, 1 drop here, and you would also do a drop to do the RH to see if they have the RH antigen or the D antigen. Remember, 85% of the population has the D antigen. So we'll talk about these 2, and I know there's nothing here, but I'll kind of talk about the RH a little bit. So what you do is then we have 3. If remember, we have 3 little tubes, okay, that we then, there's the anti-A tube, which has blue fluid in it, the anti-B fluid, which is yellow, and then there's an anti-RH. When we say it's anti-A, the fluid in the little container is anti-A, that means it has A antibodies in it, okay, it has A antibodies in it. The anti-B little fluid has B antibodies in it. Okay, it has B antibodies. And the anti-RH tube has RH antibodies in it. Okay, so we're trying to figure out what antigens the blood has. So we're going to put antibodies on each of them. Okay, remember, if the antibodies and the antigens match, if they are the same, then what's going to happen is the blood is going to agglutinate. It's going to clump. those antibodies are going to grab the red blood cells and it's going to clump. Okay? This is clumping. Okay, this is what clumping looks like. This is not clumping. These have not clumped. Okay? So we are putting antibodies on the red blood cells. Okay? If it clumps, then you have that antigen. If it clumps, if you put an antibody on it and it clumps, then you have that antigen. Okay, so let me give you an example. So here is type AB. So we put A antibodies on this blood. So we had a little spot of blood, we put some A antibodies on it, and notice that it clumped. That means that those A antibodies that we put on it matched the A antigen and it clumped. So this person has A antigens on their blood. We put the B antibodies on it and it also clumped. That means the B antibodies matched with the B antigens and it clumped, so that means they have the B antigen on them. So this person is type AB because they have both antigens on it. Here's type B. So we put type A antibodies on this blood, this drop of their blood, and there's no clumping. That means the A antibodies had nothing to bind to. They had nothing to bind to. So they don't have A antigens. Over here, we put B antibodies, anti-B on there, B antibodies, and it did clump. So that means they have B antigens. If they have B antigens, then they are type B blood. Here, again, we put A antibodies on this drop of blood, and it clumped. Okay, and it clumped. That means that they have, just like up here, they have A antigens, so they have A antigens. Over here, we don't see any clumping. There's no clumping. So that means we put B antibodies on it, but there was nothing for the antibodies to bind to, so there are no B antigens. So in this case, the person has A antigens, which means they are type A. Go down here, type O. Remember, type O has neither A or B antigens. So we put A antibodies, there's no clumping. There's nothing for those antibodies to bind to. So there's no clumping. So there's no A antigens. Here we put B antibodies. There's no B antigens. Okay, no B antigens. So there's nothing to bind to. So there's no A, there's no B. That means they're type O. Okay. Now, what happens if they're Rh positive? So let's say they're O positive, which is the most common blood type. So pretend, use your imagination. I couldn't find one with all three on it. Here we have another spot of their blood, same person's blood. We put Rh antibodies on it. We put Rh antibodies and it clumps. Okay, and it clumps. If it clumps, that means the Rh antibodies could bind to the Rh antigens and that they have the D or the Rh antigen on it. So they would be O positive. Okay, O positive. Let's say they were O negative. Same thing, it will look like this. Put a spot of blood, put the A antibody. They don't have the antigen, so the antibody can't bind to anything, so there'd be no clumping. So they would be O negative. Right, and the Rh would work the same for all of these. Okay. So again, go back if you need to watch the video on blood typing. Go through what the antigens are, what the antibodies are. In this case, we are putting antibodies from a little tube, okay, different antibodies on these blood droplets to determine which antigens they had, okay, to determine what antigens they have. All right, if you have any questions on that, please let me know.